Started? Yep. Okay, perfect. So minerals. Minerals have a couple of really, really distinct qualities about them, okay? All minerals are naturally occurring. Think there's two C's and two R's in occurring?
I don't know.
Is that right?
I don't know.
I don't know. Whatever. Again, I don't teach you words. I teach you science. So they're naturally occurring and inorganic. What does that mean? So naturally occurring.
They're already in nature?
Yeah. Formed in nature, not in labs. So again, remember, minerals are different than elements. Okay? Elements, not all of these are naturally occurring. All of these ones in white, okay? They're synthetic, ones that have been made in a lab. Alright? Minerals, however, are made of chemicals. Made of elements. Okay? So they're naturally occurring. Inorganic, what does that mean?
Means that they're not alive.
Or have ever been alive. And that's an important distinction. Okay? So inorganic not alive, I guess, and I should say, or come from living things. Okay, so let's list salt. Is salt a mineral?
Yes.
Yes. Okay, because it is naturally occurring and it is inorganic. Comes from the earth, not ever been a living thing. Okay, so mineral. How about sugar?
No.
Sugar is naturally occurring, but it's formed from plants. Okay, that's where sugar comes from. Okay, so not a mineral. Formed by plants. How about coal?
Yes.
Anybody know what coal is?
Oh, wait. It's fossil.
Coal is basically just dead things that have been, and all of the stuff has been squished out of them except for the carbon. Okay? So coal is not, because this used to be living things, not a mineral. Okay? So does everybody get this one? We're good there? Alright. So, minerals are naturally occurring and inorganic. They also all have a specific chemical composition. Okay? SiO2. That right there is a type of silicate. Okay? Specifically, this is what quartz has. Has anybody ever found quartz or seen quartz?
Yeah.
Has anybody not seen quartz? Okay. This there's lots of different types of quartz, okay? I'm just going to pull out like the most basic. This will be a quartz. Alright? So, SiO2. Now, some other things have SiO2 as their chemical composition. So how do we tell quartz apart from the other silicates? Okay, and that's where we come down to the third characteristic of minerals. All minerals have a definite crystalline shape.
Yeah, I got one. That's an H.
What?
How do you spell crystalline with an H?
Me too, Angel.
How do you H?
Where would you put the H?
Well, after the C.
Yeah,
I know.
Yep.
Like Chris? Like the name Chris?
I mean, I didn't do that.
Anybody else wanna?
Crystalline.
Okay. So, quartz specifically, all right, and that wasn't a great example of it. If you were to break it down more, you could see this. Let me pull up a picture of quartz on the Magic Smartboard. Quartz. Ugh. So, here's a pretty good example of it.
$27 one. How much is
Or here's a bunch. Okay. So this might look like that's been manufactured, but if you were to actually sit there and break it at quartz, it breaks off like that, okay? Quartz specifically has a crystalline structure where it is a 6-sided crystal. I almost put an H there because you...
That's because it sounds right.
6-sided crystal with a pointed end. Okay, so if you're talking about quartz, meets both of these, okay, inorganic, naturally occurring. It matches this because it's always SiO2, quartz is always SiO2, and it's got a definite crystalline shape.
Do all minerals do that? Like have their own little shape? Like salt's a square.
Yep, generally, yep. They pretty much all, and some of them have the same shape, like gypsum and halide, which is salt, both form squares, but they have different chemical compositions, okay? So, that's when we start getting into talking about how you tell different things apart, okay? But all minerals have those 3 qualities, okay? Naturally occurring and inorganic, definite chemical or specific chemical composition, definite crystalline structure. Any questions about any of that? Okay. Give you guys about 2 minutes to get that written down. If you want to take a relaxed break, that is fine. I don't know. Okay. Perfect. Okay, so we got to talk about, there's 2 main ways that minerals form, okay? So mineral formation. Can anybody take a stab at one way that these might form?
Pressure?
Kind of.
Heat?
Heat from?
Pressure?
Lava.
Friction.
Not lava. We'll learn about the difference.
Magma.
Magma. Magma's underground, lava's above ground. Okay? So, one of the main ways that these are made is through magma. Okay? So, magma melts minerals. Okay? Magma itself is just rocks and minerals.
You spelled rocks with 2 R's.
No, what? Where?
Cheating.
Oh. Rocks and mineral. Where would you put the second R? This isn't Spanish. You don't put an R at the front of it.
I put it after the capital R, because that makes sense.
Alright, so rocks and minerals that have been melted and are below ground.
You really messed me up here.
Yeah, I know. We're so organized. And then... No, I wasn't.
My brain just kind of... Anyway, so these melt the minerals, and then as magma cools, minerals crystallize. No H in crystallize.
I know, it's so hard. Oh, there's an R though.
Yeah, that's the sound, okay? Alright, so,
No, I passed it too.
what do you think could affect what minerals are available in specific areas? A couple of things.
Temperature?
Yes, okay? So, minerals melt and cool at different temperatures, okay? So you're gonna have places where there's like less volcanic activity, less magma. There's gonna be different minerals than you would have at a very volcanically active site, okay? What else?
Fresh.
Not really pressure, time,
Time.
okay? So time, the longer minerals have to cool, the larger the crystal, no H. Yes, there's an R.
That R got me.
Will be. Okay? So are there any questions about that? How it forms via magma. Okay? So basically just has to do with temperature, time, and I guess I should also mention available elements. Right? Hard to make quartz if there's no silicon available. Right? So this is way number 1 out of 2. A lot of stuff. This is like 3 classes,
I get
okay?
it. Don't you worry, I get it. You know, 1 is like, you know, I wonder how big 2 is. And 2 is like bigger than 1.
Actually, the 2 is smaller than 1.
But 2 is double though.
Wait, what's it like? Isn't that big actually?
I took up like half a page. Oh no, it didn't.
There's
Okay, also like there's the gap, and then
Okay, so the second way that these form is by solutions. Okay? So, with some minerals and some rocks, okay, these will get dissolved. 1S. I don't know why I want to put 2 S's in dissolved.
Spending too much time with Angelia.
I know. So these dissolved minerals in water,
reflection on the screen. I can't see the words.
So bad.
so dissolved minerals in water are present, okay? Eventually, water evaporates. Okay, so when you evaporate out the water, and you have all those dissolved minerals, what are you going to be left with?
Come in the mineral.
Solid mineral.
Rock.
Well, at least a mineral. So there's a difference between rocks and minerals.
Just obviously.
Okay, so
I don't know.
eventually water evaporates, leaving solid mineral in its place. Okay? Anybody got a guess as to what these type of minerals are called?
No. It's a mineral. Like it probably is a mineral. Oh no.
It is, but it's got like a special name. Like you're a person, but your name is Angelia.
He knows.
I'm hitting to throw you into a wall.
Shh, this is being recorded. Okay, what they are called is evaporites. Okay, that's the special name for them. Oh, real special.
Angelia, you are
So with mineral identification, there's several different ways that we look at. Now, something that you have to understand about mineral identification is you cannot rely on one property alone. Okay? There's lots of different properties. You have to use a combination of them. James, do you have a question? Sorry, I just wasn't sure with it. Oh, you're holding it up. Okay. Okay. So, let's go through these. And these are going to be the different kind of identifying properties that you guys will use both later today when you're just kind of checking them out and looking at them. All right, I want you to be thinking about these things that we're going to go through. And then on Thursday, that's what the lab's going to be about. Okay? So one that we've already talked about, crystal with an R and no H.
Alright, thank you. This is taking me a minute.
Oh my God, you're making me doubt how to spell things now. Oh yeah. So crystal form.
Welcome to Angelina. Let's her up here.
Okay?
That's not how you spell crystal.
I know it's. There's no A there, is there? That is-
Yeah, Joel. With one A.
Hmm.
Just kidding.
I think the reason why you keep wanting to spell it with an H is because Crystal in our class had it an H.
I would've.
Hey, Angelina, you're in this spit zone. Can't turn around.
Sorry, math.
All right, so crystal form. Again, like we talked about, minerals have specific crystal forms. Quartz. Again, that's the six-sided with a point. Okay. How about halide? We're not going to go through all of these. I'm just using a few examples.
Oh, stop. It's square.
Yeah, perfect cubes.
I was so confused.
Okay, so those are two examples, but crystal forms, so they form unique crystalline shapes. Okay? Again, that's one that probably you guys should already know. Well, not already know, but know from earlier when we were talking about it. How about the next one? Luster. Okay, anybody got a guess as to what luster might be?
Pineapple cake. I don't know. What's a wild guess? Like the shine to it?
Yes, basically. So it is how the mineral reflects light. Okay, we have two main types. Okay, two main types of luster. Anybody got a guess as to what those might be?
Light and dark.
Not quite.
Like matte and shiny.
Kind of. Think of that a little bit differently. What's something that light reflects really well off of?
Salt.
No,
Color.
not a color.
Shiny thing?
Mirrors.
Smooth?
Sharp ankles.
Metal.
Metallic. Yeah, good job.
Whoa. So many things. This
Okay.
glass right now, I can't even
So
see.
metallic, if it shines off of a mineral and you would say it has metallic luster, this means it looks like light off metal. Okay? So, let me grab a metallic lustered mineral.
Do you mind turning off the smart board?
Fine, oh my
Because
God.
it reflects.
It's
It
hard.
really
It's
hurts my
hard.
eyeball.
You can't. It's hard to see.
Close your eyes. Close your eyes and I'll tell you what you're writing. You have it. Let's see.
Close your eyes and write what you were supposed to write.
There we are.
Hopefully it makes
Hello, I
sense.
try to copy something and just start to go with
Can
that.
everybody see that?
It looks like, no?
Looks like a
Oh, it's a little
rock.
shiny. It's got a little bit of shine to it.
Yeah.
Pass that
A little bit of
around.
sparkle.
It just looks like
Yeah,
a rock.
it's
You would
sparkly.
say that has kind of a metallic luster.
Rocks remind me.
I needed some galena.
Third grade. Sparkly. Yeah, like who wrote that?
Probably.
Metallic. What about sparkly? Doesn't sound as science. Purdy.
Yeah, it's like such a scientific wording.
This one would also probably be considered that way. Stupid galena.
When you mad at a rock, but you're also a science teacher.
Nice.
That's not the computer. That's the computer.
I like how you know exactly what that sounds like. I don't like these things.
Oh, it's not me. I almost wrote it down. Kitty.
Oh,
I don't know why I can't call it science.
you see that like sheet thing?
It's not science.
Science? Oh, I thought you said what?
I mean, I must have. I didn't mean to.
No, Give it his Hanson. Oh, it's Hanson.
Alright, so
What's this?
on this, you guys can look at some of these. Please stop doing that. You can look at some of those and pass them around. Some of those definitely, you can tell which ones are metallic more than other ones, correct?
You want this back?
Yes.
Does anybody else want it? My God. Anyway, so
That's it?
So non-metallic is the other one. Okay? Now, with non-metallic though, you kind of describe more what it looks like. Okay? So like something might look more waxy. Some of it might look more matte, like you've said. Okay? If it's a non-metallic luster, you describe what it looks like. Okay? So non-metallic lusters describe what okay, so you're gonna have things like waxy, earthy, soapy, okay? Those kind of things. Alright? Any questions about luster?
No?
Perfect. That's what I like to hear. Alright. Is everyone done writing? Is there anyone who's writing? Alright, I'm gonna erase this so I can have more room.
Sure.
What? I feel like I'm really being attacked today. Okay, so the next one is hardness. Okay? So for measuring hardness, we use something called the
Rock test.
Mohs hardness scale. Okay? Are we okay? We're gonna survive. So I'll just take a big deep breath. Okay, so the Mohs hardness scale is basically determining how hard something is or how easily it gets scratched. Okay? And so, this is in a scale from 1 to 10. Alright? What?
Keep it simple, 1 through 10.
Yep. No, I gotta remember exactly what goes with what.
Ready? This is
I know.
like if you touch it, it's like
Okay, so basically, this is kind of how it goes. Things that are on the 1 to 2 in terms of hardness. This would be like talc. Does anybody know what talc is, or like talcum powder?
yeah, like baby powder.
Yeah, the mineral that comes from before it gets broken down is in this range. And you can scratch that with fingernail. Okay? So if it's in the 1 to 2 range, you can scratch that with a fingernail. 3 gets scratched with copper. Okay? So if you can scratch something with copper, but you can't scratch it with your fingernail, it's a 3. Okay? Now this doesn't mean you can't scratch talc with a copper. Okay? C-O-P-P-E-R. Okay, so if it is in the, how do I want to put this? Steel, like a steel nail, all right? That's going to be in the, I wrote that wrong. 4 would be with steel. 5 and 6 is going to be glass. Okay? So if glass can scratch it, then it is a 5 or 6. If it scratches glass, then it's above that. Okay? Now we have these things called streak plates. Okay? Streak plates are at a 7. Okay? 6.5 technically. Alright? And they're just made of porcelain. .5 is a streak plate. Now we know this because anything above a 6.5, so like quartz is a 7. Quartz will not leave a streak, and we'll talk about what a streak is in a second. But so things that can scratch quartz are obviously above a 7. If quartz scratches it, it's below a 7. Alright, does that make sense? There are some things that are in 8 and 9, but really those are kind of a hodgepodge. You just kind of have to test things. Anybody know what the hardest thing is?
I would love to say bedrock.
It's heartbreak. No, I'm kidding. Diamonds.
Oh yes.
Diamonds rank 10 on the Mohs hardness scale. Okay? Are there any questions about any of that?
Why aren't there 8 and 9 on the scale?
There is. I mean, they're just
It's
less.
not like important ones.
They're less common things. Topaz is an 8.
What?
Corundum is a 9. So it's just kind of
That's just fun.
whatever. You know what I mean? So I wouldn't worry too much about those. Has anybody got any question about hardness? So since we brought up streak, anybody have a guess what streak might be?
One of these and other things?
Yeah, kind of. Alright, that's the next one. This is the color of mineral in powdered form. So, there's a problem because there's some minerals that won't leave streaks. Minerals above 6.5 won't leave a streak. Okay? So, minerals 7 or higher don't leave streaks. Okay? Does anybody know? So gold is a mineral, okay? But so is pyrite. Okay? Anybody know the name for pyrite? Fool's gold. Okay? Gold won't leave a streak. Pyrite, we take it. Black streak. Okay? Get rid of that so you guys can see that again. Again, you guys can mess around with this stuff. Again, there's nothing there, right? Black streak. Let's see, is there... Ooh, some uranium. Iron. I mean, that's the thing. You just test some of these. It's a red streak. Okay? So things with a really high iron leave red streaks. Okay? Iron leaves kind of a reddish color. Is there any questions about streaks? Streaks pretty easy one. Alright? Speaking of color, so when that's the color of the mineral in powdered form, you can also use just the color. Okay? And that's pretty simple. The look of the mineral color. That's all it is. Color is simple. Okay? A lot of these are pretty simple. Alright. We'll do one more, and then we'll take a break before we get to the last couple, because the last couple are a little more complicated. Okay? Texture. Anybody got a guess as to texture?
Wait, feel?
Like whether it's like smooth or like bumpy and rough.
So more, I'm going to go, the more, you're getting very specific, those are some of the examples, like smooth or waxy or soapy or whatever, how it kind of feels. Those are examples, gritty. But yeah, it's, to put it simply, texture is how the mineral feels. Okay? And there's no like special thing there. You literally just describe how it feels in your hand. Okay? Now, there's going to be, like if you were using like a mineral identification guide, where it would have like a chart, and you got to texture, and you were feeling something, you're like, oh, this kind of feels rough. And then the thing says gray for that one. Those are just two different interpretations of basically the same thing. Okay? Does anybody have any questions? Okay, let's take a little break. Make sure you guys get that all done. So, here comes the last, or the first of the three things. Number one. Density. Yeah, this is still part of all those.
Oh!
This is just another identification step.
Just put together some bullet points and that's not so.
Ugh.
So confusing. So Schultz.
There.
Thank you.
Bullet point.
You put in the same thing.
Alright, so density. Okay, this is an object's mass divided by its volume. Now, it's pretty hard to tell the volume of like,
Well,
you know,
tiny little thing though.
this thing, right? It doesn't have like a, there's no really good formula to throw that into, right? You can't measure its length times width
It looks like a ball.
times height.
It looks like, yeah, it's gone.
Oh, a ball. I thought you said a volleyball for a second. I was like, I don't think so. Anybody know what that stuff I just held up was?
A ball like cereal.
Track.
Smells like rotten eggs.
Sulfur.
Oh, yeah.
I was gonna say eggs.
Yep, eggs are a well-known mineral. Okay, so how would we take the volume of something weird like that?
Estimation?
No.
No, I'm.
Yep.
Oh, water.
So, if you take like that weird shaped thing, and you have a graduated cylinder, it has 50 milliliters of water, and you drop it in. Well, don't drop it in because then it'll splash and it's a big mess.
I'll be
Um,
inaccurate.
So place it in there, okay? And it goes up to 54.6. How many milliliters of volume does that thing have?
6.
4.6.
You have 50 milliliters and it goes up to 54.6.
Okay.
Oh.
So add a set amount of water to a container place object in difference between final and initial volume is volume of object. Yay. Okay. Any questions about that? So density is pretty simple. There's also this thing called specific gravity. We don't really need to get into that because we don't really have the stuff to measure specific gravity. It's a little. You don't need it. You don't need it. Okay. 2 more.
Oh, yay!
You guys ready?
No.
You excited?
No.
He's excited. That's all I needed. Okay, so this one is called. They're kind of the same. They're not the same thing, but they talk about the same thing. Cleavage and fracture. Okay? And this is basically talking about how minerals break. Okay? So fracture, if something fractures, how do you think it breaks? Or just
Pressure,
kind
like
of.
one.
Like just a little crack, like anywhere on like a scale from just a little crack to like shattering.
So fracture. So say you took a mineral and you just like snapped it. Okay, you're super strong and you can just snap minerals. And it just has a bunch of jagged. There's like no rhyme or reason. Okay, you would say it fractured. Okay, it has no cleavage. All right, so fracture breaks randomly. Now, if you break something, so let's say you talking about halide, right? Or halite, excuse me. Halides are a type of thing. Halite is the mineral. Halite has cube, right? How many different planes is that? 1, 2, 3. There's 3 different planes that it breaks along.
Oh.
Okay, there's 6 sides, but 3 different planes. Okay, so cleavage breaks along planes. Okay, so if there's like flat edges, it has cleavage. Okay, and you would say specifically how many planes it breaks along. Okay, because some things only break along one plane. Let me find mica. Okay, so go ahead and put anything else you got out of the way, because we're going to talk about
Special people. Is this another bullet point deal?
yes. Sorry. Okay. This is easier for me to bring, so this has specific, easy to remember examples. Okay. So some minerals, not all minerals, have unique properties. Okay, so let's say you took a piece of iron and the iron got attracted to this metal. What would you call that?
Magnet.
Magnetic, okay? That's why they named it. Magnetite attracts iron, okay? So that's a special property of that specific thing. So, if you're going to talk about what do you think fluorite does? Stick it in the sun, then you stick it in the dark.
It glows. It glows.
It glows. It fluoresces. Fluorite. Okay?
Crazy. You can see it's black. Oh man.
I'm getting ukulele lunch in the next room.
Okay? So we got those two. How about what do you think calcite might do?
Is it calcium?
Well, it has something in there. When you put hydrochloric acid on it, what do you think it does?
It dissolves.
Nope.
It blows up.
Nope.
It lights on fire.
Well, we're taking a lot of guesses. We've used the word already at least once today. I think all of you've written it down.
It effervesces.
It does! It effervesces!
What does that mean? I don't remember writing that word down.
Effervesces. So it essentially, basically what effervesce means is it's going to bubble and release hydrogen gas. Okay? And these are just some examples. There's more things that do other things. Alright? Lots of things have special properties. But I'm not going to go into every single special property because I don't need to. You guys are very smart and you'll figure it out all by yourselves.